Hello. Today we're going to be talking about transformations, specifically translations. Translations are the easiest type of transformation there is, and if you don't know what a transformation is, it's any type of change that maps a specific set of points. Let's say this word translation right here is a set of points. It's called the preimage, and it maps that preimage onto a final set of points called the image. And a translation is a type of transformation that maps the preimage without changing its size, shape, or orientation. So let's say that this is the y-axis right here, this black line, and it's oriented so that it's facing up to the positive y. So let's say we would, this is the direction that we're going to translate it in. So it would end up like this, in the same orientation, it's the same shape, the same size, and it's still facing up towards the y, but it's now in this location instead of here. So you can think of it as sliding an object around. And this arrow right here is called the translation vector, and essentially tells you what direction you move the preimage in and how far. So this length right here is how far you would move the preimage to the image, and the direction it's pointing in is what direction you're going to move the preimage in. So now let's get started. As I said, translations are pretty easy, so you shouldn't have too much trouble with this. Let's go over some basic things first. So I'm going to need a pencil and some paper. Okay, so let's start with some of the basics. So let's say you have a point right here. We'll call that point A. And you're asked to translate it in this direction for this length. Well, this actually means the exact same thing as if it asked you to translate this point in this direction and that length, and this direction and that length, because all of these arrows are the same length and point in the same direction. So it doesn't matter where on the paper it is relative to the point. You just need to be translating it in this direction and this distance. So when you're translating it, all you need is a straight edge. So you should act as if the vector has an endpoint of the point you're translating. So you're going to be copying the vector with the same distance and direction onto the point. So let's just use this one, even though they all mean the same thing. So first, you copy the slope of the vector, and then you can move it down over here. Since I'm freehanding it, I'm just going to be eyeballing it, but if you had a compass, then you could make a parallel line over here and copy the length of this vector. So I'll just copy the slope, and then I'll approximate the distance. So I think it looks to be about this long. So the image would be right there. And then if I want to do it over here, I would do the same thing, copy the slope, and then approximate the distance. So let's move on to something a little more complicated. Let's say we have a triangle, and it wants us to translate it in this direction for that distance. So you have to translate each of the points first. So you would just do the same thing as I showed up there. You translate the slope of the vector 3 times. And you just connect the dots, and then you get your triangle. So now let's move on to a few other examples. So we're just doing the same thing as over there. This is synthetic translation, since you don't have the background coordinate plane. But you can just repeat the same steps as I showed you earlier. So you can pause the video right now if you want to find out how to do it on your own. But I'll just continue for right now. So you just copy the slope, move it over, draw the line, repeat the process for each of the other points, and then you can estimate the distance. So say about right there. And then just connect the points when you're done. So when you're finished, it should look something like a prism, since you have these lines and you have these two which look like bases. But it should be noted that these lines and the original preimage are not part of your answer. Your answer is your final image that's right here, the one that you translated over. So let's go on to the next one. So this one's a quadrilateral. So the thing is, it gets more tedious with the increasing number of points, because there's a larger chance that you have of messing up, because the amount of lines you have might blur together and then you get mixed up. But just keep an eye out for that and just keep doing it. So I'll just repeat the same process. You can pause the video and see if you can do it yourself. So here's what I'm talking about. So we have these two lines right next to each other. So if I were to draw this line, it's hard to tell the difference between them. So you're just going to have to watch out for that and make sure you can keep track of which point is which. So obviously it wasn't perfect because, of course, I'm freehanding it, but it's close enough. If I wanted to, I could secretly just move the point over and erase this line and just draw the actual one, but this is good enough for now. So if you have a compass, then of course you could make the parallel lines and draw it out much better than you could with just your pencil. But since I don't have a compass, I'll just be using freehand for the rest of this video. So now let's go on to some analytical problems. So as you know, that means that there's a background coordinate plane. So now you can't use just intuition and your ruler in order to translate all these shapes. You have to use your algebraic knowledge and your knowledge of coordinates in order to translate all these shapes. So here's the rule you have to follow. When you're translating along a vector, you need to follow this. So say you're translating along vector AB. So that's the standard notation of vectors. So let's say this is vector A and this would be 0, 0. Then this would be AB. And then you would call this vector AB. So let's say you're translating a point down here that has coordinates of x, y. Then in order to get up here, then this point would turn into x plus a and y plus b, because this translation vector is AB, so you would just add that to each of the coordinates. So just remember that. So if you're actually doing it out on a coordinate, you don't actually have to write down all the numbers and add x plus a and y plus b manually. You can just count it over and up or down. So it's much easier if you're actually drawing it out. If you're having to write down, like maybe it'd ask you, these are the points of a triangle, and then it would say this is a vector that has to go to, list the points that are in the image. So then you'd have to add out all the numbers. So now let's do a problem. So here it says to translate this triangle along a vector 5, negative 1. So you can just use this rule right here. You add the a to the x coordinates of each of the points and the b, so that'd be negative 1 to the y coordinates. So let's add 5 to a first. So negative 3 plus 5 would be 2. Or you could count over 1, 2, 3, 4, 5. So this would be, okay. So then I'm sorry, I messed up. So you would count over 1, 2, 3, 4, 5. And you would also count down 1. So negative 1. I messed up there, sorry about that. So then you do the same over here. 1, 2, 3, 4, 5, down 1. And then 1, 2, 3, 4, 5, down 1. So then you would have your 3 points, and then you could just connect it all together. So as you can see, you have your final image from the vector 5, negative 1. So that was pretty easy. Just remember to do both, unlike what I did. So now let's do this one. As before, now there's more coordinates, there's more points, so there's a larger chance that you'll mess up. Just be careful. So translate translate square ABCD along vector 3, 4, and then along vector 1, -5. So now you have to translate it twice. So you have to do one step at a time. So you can pause again, see if you can figure this out on your own. You just repeat what I showed over here. So let's just do it together right now. So we'll start with A. 1, 2, 3. 1, 2, 3, 4. So then you have that, but now you have to do it along the vector 1, -5. So we'll do the same thing. So we don't have to draw on the lines because that's just extra work. So now we'll go 1 and then down 5. 1, 2, 3, 4, 5. So then and sometimes with these shapes you can cheat a little because you know it's a square, so all the sides are going to be the same, so you could just count just what one of the sides were and then copy that around each. So you'd count, this was 2 units over, so 2 units down, 2 units over. So then you could just get the answer like that. So this is your final answer, this square right here. So that was translations. It's pretty easy, so you shouldn't have any trouble getting the hang of it. I hope that didn't help get better grades in your test.